Dave has $1,000. A stranger just made him an offer. Flip a coin. Heads, the stranger gives him 50% more. Tails, Dave hands over 40% of what he's got. Dave does the math in his head, the way anyone would. Half the time he gains $500. Half the time he loses $400. Run the numbers and the average outcome is a 5% gain. Every textbook on the planet says, take this bet. So Dave takes it. Forget Dave for a second. Picture 10,000 people standing in a stadium. Each one gets the exact same coin flip. Each one plays it exactly once. Half lose, half win. Pool every dollar in the building and the total grew. 10 million walked in. 10.5 million walked out. The math behaved exactly the way the formula promised. Dave isn't 10,000 people, though. He's one person, and he's not flipping once. He's about to take that same bet, the same coin, 10,000 times in a row, because that's what an actual financial life looks like. Not a crowd, a sequence. Watch his money move, up, down, down again. It doesn't drift toward the average everyone promised. It falls off a cliff and stays there. Dave took a bet with a guaranteed positive expected value, played it exactly as told, and ended up with nothing. A bet that enriches a crowd can quietly bankrupt the one person actually playing it. That single fact explains why leveraged ETFs grind down retail portfolios that never technically crashed. It explains why a startup can win 3 brilliant funding rounds and still hit zero. It's why hedge funds running positive expected value strategies blow up almost on schedule. Stick around and you'll see this trap coming before you're ever standing inside one. Start with the math nobody disputes. Expected value means taking every possible outcome, multiplying it by how likely it is, and adding the results together. For Dave's coin, half the time his money gets multiplied by 1.5. Half the time by 0.6. Average those two multipliers and you get 1.05. Every flip, the formula says his wealth should grow 5%. EV equals 0.5 times 1.5 plus 0.5 times 0.6 equals 1.05. A 5% edge, repeated indefinitely, is the kind of number quant funds pay teams of physicists to find. Dave just got handed one for free in a stadium full of strangers proving it works. So picture the stadium again. 10,000 people, $1,000 each. The coin flips once, simultaneously for the whole crowd. 5,000 walk out with $600. 5,000 walk out with $1,500. Added up and $500,000 got created by a single flip, spread across the room. The crowd's average rose exactly the way the formula said it would. That stadium is the picture classical economics paints every single time it tells you to accept a positive expected value bet. Now Dave leaves the building. There's no crowd left to average against. He's alone with his $1,000, flipping the same coin, only sequentially now. Flip 1, heads, $1,500. Flip 2, tails. 40% of $1,500 is $600. Subtract it, $900. One win, one loss. The exact 50-50 result the formula predicted. And Dave is sitting on a 10% loss. Expected value promised 5% up. Reality delivered 10% down. Same coin, both times. This is precisely how a leveraged ETF investor gets wiped out holding an index that never actually crashed. The market drops 5% Monday, recovers 5% Tuesday, flat for the week. A fund built to triple that daily swing drops 15% Monday and only claws back about 13 on Tuesday, because 15% of a smaller pile is a smaller number. Flat market. Permanent loss, nobody touched a thing. The geometry did it on its own. Maybe the fix is patience. Keep flipping. The edge is mathematically real, so surely playing long enough drags the average back up eventually. Run it 10,000 flips deep and watch what patience actually buys you. The line spikes briefly, convincingly. Then it falls and falls further, and every spike gets smaller while every drop gets sharper, because each drop is now multiplying an already shrunken number. The longer this runs, the closer the odds of ending at zero creep towards certainty. More time doesn't rescue the bet. More time is what executes it. This is where the contradiction stops being a coincidence and turns into a law. Money doesn't add, it multiplies. Dave's balance after flip 10,000 isn't his starting balance plus 10,000 separate outcomes. It's his starting balance times every outcome, chained together. The moment one multiplier shrinks far enough, everything stacked on top of it shrinks with it. That's the absorbing barrier sitting at zero. Multiply zero by anything, 50% or 500%, and the answer stays zero. Once you're there, no flip gets you back out. The climb back is never symmetric with the fall either. Lose 40%, and you need a 67% gain just to break even. Gain 50% and a 33% loss wipes it out completely. Every step toward the barrier makes the next step closer to it a little easier, and the next step away from it a little harder. There's a name for a system where the average across many parallel copies matches the average along one single copy over time. Ergodic. Gas trapped in a box is ergodic. Measure one molecule for 10 years, or 10,000 molecules for 1 instant. Same number, either way. Dave's bank account isn't gas in a box. It isn't ergodic. The stadium and Dave's own 10,000 flip sequence aren't the same calculation wearing two outfits. They're two different mathematical objects. The stadium's average has nothing to say about Dave's path because Dave never gets to live in the stadium. He only gets the sequence. So what's the real number for that sequence? Skip the simple average. Take the average of the logarithms instead because that's what actually measures repeated multiplication. G equals 0.5 times natural log of 1.5 plus 0.5 times natural log of 0.6 is approximately minus 0.05, not positive 5%. Negative 5% per flip. Eventually, that guarantees ruin for anyone who keeps playing. Same coin, same 50-50 odds. Two correct calculations, two opposite answers. One describes a crowd Dave will never live inside. The other describes his actual life. So Dave's back at the table, the coin's still sitting there. He knows the trap now. The fix isn't refusing the bet. There's a real edge buried in that coin. The fix is changing how much of himself he puts in front of it each time. Instead of staking everything on every flip, Dave stakes a fixed slice, 20% of whatever he currently has. A win grows the slice, a loss shrinks it. The other 80% never touches the table, so the barrier at zero is never one bad flip away. Run that version 10,000 times and the line doesn't crater. It climbs slowly the way compound growth is actually supposed to look. That's the real mathematics sitting underneath advice you've heard your whole life and probably never questioned. Never risk what you can't afford to lose. It was never just a comforting platitude, it's a geometric proof minus the algebra. For decades, economists watched ordinary people turn down good-on-paper bets and decided something was wrong with them. Overly cautious, irrational, in need of correcting. Nobody turning down that bet was actually wrong. They were solving for the time average by instinct, while the textbook was still solving for the stadium. That wrong number didn't win by accident. It won because it's convenient. The crowd's average is one clean line on a chart, easy to model and easier to sell. A single sequential life with its absorbing barrier and its lopsided falls refuses to sit that neatly on any chart. So the chart won, and the chart got sold back to Dave and to you, dressed up as advice. Nobody actually gets a stadium. Everybody gets one thread through time, running in a single direction. Any formula that quietly borrows the average of a crowd you'll never belong to was never describing your life. Next time someone hands you a number that sounds too good to be sequential, you'll know exactly where to go looking for the barrier.